Good morning, students. Today we will study the images formation by the concave mirror. We know that we have two type of mirrors like the concave and the convex mirror. Now in this part, in this video, we will study how can we obtain the image by using the concave mirror. As you know, what is a concave mirror? Concave mirror is just look like this type of mirror which has the polish in the outward portion, and from this inward portion we look our images. This is a concave mirror. For images formation, you can use a compass. It will be easy for you to make the images by using this concave mirror, so that you can easily find the center of the curvature. You know the center of the curvature. The center of the curvature is that part of the sphere of which the center of curvature. What is center of curvature? It means that the sphere, the center of the sphere of which the mirror is the part, is called the center of curvature. So we can find the center of curvature. We can find the center by using this compass. If we use this compass to form the images, then it is easy for us to obtain images. In this case, now we know that the center of curvature, the center of the curvature is this one. This is the point C, and we know that the focal length is half the center of curvature. So if we take this length is equal to it is about 5.6, it will be 2.8. So we can mark as like a F. Okay, so it will be easy for you to make the images by using the compass. Okay, now the rules. First of all, you should know what are the rules for obtaining the images by the concave mirror. The first rule is this one. You have to write down the rule. The rule is this: if a ray of light which is parallel to the principal axis, this is the principal axis. I have already explained to you in last lectures that this is the principal axis. Okay, now this is a light ray which is coming from the object and it is parallel to the principal axis. So the light ray which is parallel to the principal axis of the concave mirror passes through the focus. After reflection from the mirror, you have already studied it in the part what is the principal focus of the concave mirror. So you know the light ray which is parallel to the principal axis always passes through the principal focus of the mirror. So this is the first rule. You should know this rule. Now the second one. I will not form the images by using the compass always, because it will take some time. Okay, I can prepare the image for you. This is the center and I'm preparing the concave mirror. This is the concave mirror. Okay, and you can polish it from this side. Now I have already explained you that this length is about 5.4. It means 2.7. This is the focus, principal focus. So by using this compass, you can easily prepare your images without any problem. Now the second rule is this one: if a light ray passes through the center of curvature, suppose the light ray is coming from the object and passes through the center of curvature, is always reflected from its own path. It means यहाँ से आ रही है तो यहीं पे वापस चली जाएगी. You know why? Because this center of curvature is always perpendicular to the mirror. So the light ray which passes through the center of curvature after reflection from the mirror, it always reflected from the same path. You know in a plane mirror, if a light ray is at the right angle to the mirror, it always passes through its own path. So it means if the light ray is coming from the center of curvature, it always passes through this own pathway. This is the second rule. Okay, you have to write the rules. Third rule: a ray of light passing through the focus of concave mirror. Okay, first of all I have to prepare the mirror. I am taking, this is the center, and I can take any length as the as the radius of curvature. This is the radius of curvature, and you can polish your mirror from this side, and the half of this length is called the focal length. So it is near about 2.6. Okay, this is the focal length. Now the third rule is this: a ray of light passing through the focus of the concave mirror. If a light ray passes through the focus of the concave mirror, which is coming from the object, okay, this is light ray which is coming from the object and passes through the focus of the concave mirror, it always, after reflection from the mirror, it always passes parallel to the principal axis. Okay, this is the converse of this one. If a light ray which is coming parallel to the principal axis always passes through the focus of the concave mirror, same as if a light ray passes through the principal focus of the concave mirror, it always, after reflection of the mirror, it always reflected in the ray which is in the path which is parallel to the principal axis. Okay, this is the third rule. And what is the fourth rule? Very rarely we use this fourth rule. Basically, in most of the images formation, we always use these two rules. It's enough for us to prepare any image. This is the center of curvature, and I am not using this compass, but you should always use this compass. Okay, again in next part I will prepare it by using the compass. Now this is the center of curvature, and the half of this length is called the principal focal length. Sorry. So the fourth rule is this: if a light ray coming to the this incident ray is always if it incident at pole, if the light ray incident at the pole, you know the pole, this is the center of this mirror. So if the incident ray is incident on a pole, it always reflected making the same angle with the principal axis. It means this angle will equal to this one. If this angle is, suppose it is 30 degrees, then this angle will also 30 degree. Okay, it means K on this mirror, if the light ray incident on the pole, it always reflected in the path which make equal angle with the principal axis. These angles will be equal. Actually, for any mirror like the plane mirror or the concave mirror, the convex mirror, they always follow the rules of the reflection. Okay, now this is the 4 rules which we have to follow for the images formation by the concave mirror. Now we are going to prepare the images by using the concave mirror. I am going to adjust my copy. Okay, now the first one. Now in first case, suppose we place the object between P and F. What is a P? You know the P is the pole and F is the principal focus. So you should always prepare the images by using the compass. Now, this is the mirror. Oh, okay, it is incomplete. Shit. This is the mirror. So there is a doubling in this mirror. This is the mirror. Okay, you should always prepare a single line, not this type of line. Okay, I think I should prepare again. I should make it again. This is the center of curvature, and I am preparing a concave mirror by using the compass. This is the mirror. Okay, now it is okay, and I am polishing it from the side. Now we know that the principal focus should be always in the middle of this value. That is, it is about 5.4. 5.4 half means 5.4, 2.7. Okay, and this is the principal focus. Now we place the object in between the pole. This is the pole and this is the principal focus. Now I am placing the object in between the pole and the principal focus. You should always upright the object, and I can mark it by using this A, B alphabets. This is the object. It is always erect. First we will draw the ray which is parallel to the principal axis. Okay, this is the ray which is parallel to the principal axis. and the ray which is parallel to the principal axis will always passes through the focus of the mirror. Okay, so it will passes through the focus of the mirror. It will follow this rule. When the ray which is parallel to the principal axis will always passes through the principal focus of the mirror. Now the second ray we can prepare is the ray which has the path of the center of curvature. This is a pathway of the another ray, and we know that the ray which is passes through the center of curvature is always reflected on the same path. So if the ray passes through the center of curvature, we know that this ray passes on its own path. So this rays cannot be meet in this part. It will always meet behind the mirror. It cannot be meet in front of the mirror. It will always meet behind the mirror. You should prepare your images by using the pencil. If I will prepare the images by using the pencil, you are not able to see the images, so I have to use the sketch one for you. And this is the image. Okay, sorry. This line is not, actually this is not okay. This is the object AB, and this image is A dash B dash. This is the image. Okay, so you can mark it like the symbols A dash B dash. This is the image. And what can be the nature of the image? If we start from this part of the object, this is the head of the object. So when the light rays meet at the point, we say this is the head of the object. So this is actually the head of the object. Now we know that the object is erect. It means सीधा है वो, है ना, inverted, उल्टा नहीं है. तो first the nature of the image, you can write the nature of the image after preparing the images. First is it is erect. Second one, we know that this image is larger than the object. The object is of a smaller size and the image is larger in compared to this object. So we can say it formed the enlarged image. We can say it form a enlarged image, larger than the object. We can write there larger than object. This is the nature of the image. Okay, now the third point is we know that the image is formed behind the mirror, and the images which are formed behind the mirror is always virtual. So we can say this is a virtual image. This is a virtual image. Okay, so these are the nature of the image formed by the concave mirror when we place the object between the F and a P. And you should write here the image formed when object is placed between F and P. Okay, this is the first case. Now the second one. Second case, if what will happen if we place the object at F. So I'm going to prepare it. I'm going to prepare a principal axis, and this is the center of the mirror. And you should always prepare the mirror by using the compass. So this is the mirror, and I will polish it from this side because this is a concave mirror. Okay, or if we polish it from this side, it will become a convex mirror. Now we know that the F is always half of this length. It will be about this one. So this is the center of curvature and this is the principal focus. Now what will happen if we place the object at the focus? First, the ray which will pass is parallel to the principal axis. We know that according to the rules, it will passes from the principal focus of the concave mirror according to our first rule. Okay, first one more thing you should know, that you always mark the arrows with this rays. These arrows show the path of the light ray. Okay, so you should always make the arrows for the rays. Now the second we can pass this. I have to increase the length of the mirror. We know that if the light rays passes through the path of center of curvature is always refracted in the same path. So if we draw a light ray which is passes through the path of the center of curvature, it will reflect it in the same path. Now we know that it can't be meet either in this direction or in this direction. It means they can't be meet anywhere, not here, not here. So what can be the nature of the image formed by the object which is placed at the principal focus of the concave mirror? So first you should write here, when object is placed at F. Now we are going to place the object at F, and we saw that the light rays never meet either in this direction or in this direction. So what can be the nature of the image? We can imagine that it will meet at infinity in this direction. If the light rays meet in this direction, it means the front of the mirror, we will say it will be a real image. So we can say the image will be real. This is the nature of the image. Okay, first this is a real image. Second one, where it is formed? It formed at infinity. So we can write here at infinity. Okay, now the third one is we can say this is a real, and real image is always inverted. You know, the virtual image is always erect. Like when you see yourself in a mirror, you always see your erect image. But the real image is always inverted. So real and inverted. Real and inverted. And the fourth one, if this light rays is meet at infinity, it means a magnified image is formed of this object. So we can say the highly magnified image. Magnified. Okay, this is the nature of the image formed by the concave mirror when object is placed at F. Okay, now the third one, what can be the nature of the image when object is placed in between F and C? So we can write here, when object is placed between C and F. What is the C here? C, the center of curvature, and F is the focal length. Not the focal length. This is the principal focus. Okay, this is the principal focus. Suppose this is center of curvature, and you can prepare your images by using the compass. Now I am going to prepare the images by using the compass for you. So you should also prepare your images by using the compass. If you will not use the compass, I will really cross your images. Okay, now we know that the length of the principal focal length is the half of the radius of curvature. So it will be about this one. This is the principal focus. Now we place the object in between, not at the midpoint, in between the C and F, anywhere in between, like here, it can be here, it can be here. So I am placing this object AB in between C and F, in between anywhere at any point. Now the ray which is parallel to the principal axis, we know that it will, okay, I just forget to make the polish of the mirror. It's really important. So first, the ray which is parallel to the principal axis will passes through the principal focus, and the second one we can prepare it by using the principal focus. We can prepare the images. Like we know that if the light rays passes through the principal focus, is always, after reflection from the mirror, it will be parallel to the principal axis. According to this rule, that was the rule. If the light ray passes through the principal focus, is always, after reflection from the mirror, it will be parallel to the principal axis. So if we draw the ray which is passes through the principal axis, we will always, after reflection from the mirror, it always becomes parallel to the principal axis. So it meet here. Where it meet, you can prepare the image. So you start from the head of the object. So where the light ray will meet, it will be the head of the image. You can write here like A dash, B dash. This is the image formed by the concave mirror. Now we know that the image is formed in front of the mirror. It means the light rays actually meeting at this point. So if the light rays actually meet at the point, we can say that it is a real image. So the nature of the image is, first one, it is a real image. Why it is real? Because it formed in front of the mirror and the light rays actually meet at that point. So this is a real image. And real image is always inverted. We know that the virtual image is direct, but the real image is always inverted. The second nature of the image is inverted. Real and inverted. And third one, real inverted. If the light rays meet at the last distance, it means the image will be larger than the object. So we can say it will be larger than object. And the fourth one, where it is formed, it formed behind the sea. So we can write here that behind the center of curvature. So this is the four nature of the image formed when the object is placed in between the C and F. First one, it is a real, inverted, larger than the object and behind the C. Now the fourth condition, when object is placed at C, what will happen when we place the object at C? So you can write here, when object is placed at C. Okay, first we have to draw the principal axis of our mirror. This is the principal axis, and suppose this is center of curvature, so we can prepare the concave mirror. Here this is the concave mirror, and it should be polished from this side. This is the polished part. Now where will be the principal focus? It will be here at this point. Okay, this is a principal focus. Now we are going to place the object at the center of curvature. The light ray which is parallel to the principal axis, after reflection from the mirror, we know that it will passes from the principal focus of the mirror. Make the arrows here. Second part is this, we know that if the light rays passes through the principal focus, it will always become parallel to the principal axis. I think I make something is wrong in this picture. Okay, there is some problem in images formation. It will be, I can't rub the lines. Actually this is not the line. I'm not using the pencil, because the pencil is very light. You are not able to see what I'm preparing here, so I use the sketch pen. There is some issue in this ray, so I make it correct. I correct it. Now the image is always formed at the same point. It means this is the object AB and the image is formed at the center of curvature. If we place the object at center of curvature, the image is also formed at the center of curvature. And you will surprised to know that the height of the object is equal to the height of the image. It means of the same height, at the same distance. The distance of the center of curvature is, it means the distance of the object is same as the distance of the image formed by this mirror. So this is the image formed when we place the object at the center of curvature. So what will the nature of the images? Nature of the image formed. First, this is a real image. We know that if the light rays always actually meet at the point, we say that this image is always real. Second thing is this, real image is always inverted, so we can say this is the inverted image. Third one, the size of the object is same as that of the size of the image is same of the object. So we can say the size of image is equal to the size of object. Okay, third. Now the fourth point is this, it will form at C. The image is formed at C. So now the next image formation by the concave mirror is, what will happen if we place the object behind the C? Fifth condition, when object is placed beyond C. Okay, so this is the principal axis, this is the center of curvature, and this is the mirror. You should always polish the mirror. This is the polish. Now the focal length is always half of the radius of curvature. Now I am going to place the object beyond the C. Then what will happen? Now if the object is behind the C, first the rules are the same, rules are not changing. So first, the ray which is parallel to the principal axis is always passes through the principal focus of the concave mirror, like this. Okay, you should always make the arrows here. And the second is this, if light rays passes through the principal focus, it always passes parallel to the principal axis. You know, there are not only two rays which is passing from this object, which is coming from the object. There are a lot of rays which are coming from the object. We always prepare only two rays for our convenience. AB is the object. Now these rays is meeting at this point. So this point is the head of the image, that is A dash B dash. Okay, so this is the image formed. Now what is the nature of the image? First, it is real because the light rays will actually meet at this point, and real image is always inverted. And third is this is smaller than object, is smaller than object. And the fourth nature of the image is it is formed between C and F. It always formed between C and F. You know, this is a very interesting point. If we put the image in between C and F, it always formed behind the C, beyond the C. And if we place the object beyond the C, its image is formed between C and F. They are vice versa to each other, converse to each other. This is the fifth image, formation by the concave mirror. And the last one is the image formed by the concave mirror when we place the object at infinity. So you should write here, when object is placed at infinity. So what will happen? First, make a principal axis, and this is the center of curvature, and you can prepare your concave mirror by using the compass, and shade your mirror, and then find your principal focus. This is suppose principal focus. So suppose our object is at infinity. You know, when an object is at infinity, the rays is always come the rays is always come parallel to each other, like we are preparing these type of images in which these rays are not parallel to each other, these have a certain angle. But if we place the object at infinity, the rays coming from the infinity is always parallel to each other. So we can prepare the image like in NCERT book. It is like the right ray which is coming from the infinity is this one and this one. These are the two rays, like these two rays which are coming from the object which is placed near to the mirror. But when the object is placed at infinity, the rays is always like this. All the two rays which we have prepared in last images is always parallel to each other. Now we know that the rays which are parallel to the principal axis is always meet at the F. This will also meet at F. So now here the image will form at F, and you can make your object like this one. This can be the object A and B. So if the light ray actually meets, so we can say it means the real image is formed. This is the nature of the image formed. real, and real image is always inverted, so we can say the real inverted. In comparison to the object, can you imagine if the object is placed at infinity and you are looking from a large distance, and if you are able to see the object, it means the object is very large, and in compared to this object the image is formed is really very small. We can say this is a diminished image. So we can say the image is diminished. Diminished means बहुत ज़्यादा छोटी, diminished image, diminished बनती है. And the last is at f. So if we place the object at infinity, the image is formed at f. It is just converse of this point. If we place the object at f, image is formed at infinity. Vice versa, when object is placed at infinity, image is formed at f. And what is the nature of the image? Okay, this is real inverted, highly diminished, and it is formed at f. So these are the some rules and the images formed by the concave mirror. You can prepare a chart. In which you can write that where you are placing your object and what is the nature of the image formed by the concave mirror. So this is all about the concave mirror. In next lecture, we will study that when the image is formed by the concave mirror, so how can we solve the numerical based on concave mirror. Okay, done. Okay, bye.